Okay, here's the recording in progress. I'll share the screen. So I'm actually done with the chapter. So it'll just be a review. I will make my own review questions up. And then if you have some time at the end, you can ask me questions, and same thing for tomorrow. Okay, so they're so-called buffer days. So I'll have my own review and then let you ask questions. And when that stops, we can end the class. Same thing tomorrow. Test is on Friday. Okay, so exam 5, Friday. Coverage is only this. So you can see not that much material. 5.3 seems to be the majority of the problems, but I had some requests before, previously for some problems, so I'll be doing a bunch of them right now, presently. Okay, so here we go. Start reviewing for the test. Okay, this is 5.2, number 9. F of x is 2 minus e to the negative x minus 3. So here's the progression that I have. Okay, e to the x looks like this. E to the negative x is a reflection across the y-axis, so that's e to the negative x. And then I see e to the negative parentheses x minus 3, so that shifts 3 units to the right. So this point, which was 0, 1, now becomes 3, 1. Then I put a negative in front of the whole thing, so the picture's getting cluttered. Take that red graph, reflect across the x-axis, and it bounces over to here. So 3, 1 bounces to 3, negative 1. Negative e to the negative x minus 3. And then finally, I add 2 to the whole thing. So I keep that same general shape, move 3, negative 1 up to 3, 1, and then it looks something like that. Okay, so this is sort of progression you want to show me. Excuse me. Okay, so start with e to the x, e to the negative x, reflect across the y-axis, e to the negative parentheses x minus 3, move 3 to the right. Negative the whole thing, reflects across the x-axis. And then I made a new graph because the picture was getting too cluttered already. And then I just moved the whole graph 2 up. So 3, negative 1 becomes 3, 1. Okay. And yes, you should show me key points. There's usually a key point like 0, 1, or the vertex of a parabola, so forth, and tell me what happens. Okay, it moves over to this point or that point or whatever. Okay.
You know, this problem kind of confuses me. Like, why wouldn't we be using negative x plus 3?
Negative parentheses x.
Like, why are we moving it? Like, when I first did this problem, I moved it 3 to the left instead of 3 to the right.
From here?
Yeah, because like when you distribute that negative, you know what I mean? It's like e to the negative x plus 3.
It doesn't work that well. Okay, so it's probably better not to distribute. Okay, that's a whole new can of worms because of the fact that it's not all together. Okay, so it's better to just leave it like this. It's the best I should say.
You just kind of have to accept that the negative 3 kind of stays the same, and that's where you move it.
Correct. I first analyze e to the negative x, and then take e to the negative x and move that 3 to the right. Okay. You probably could analyze it with 3 e to the negative x plus 3, but it's more confusing. In fact, if I started off with that, I would end up ending it like that.
That's what I was just going to ask. Great. Okay, thanks.
Yeah. So e to the negative x plus 3. Yeah, I really don't want to go down that rabbit hole. It would take up too much time, and we probably wouldn't get that far. So let's just leave it as it is. Okay. 5.363, absolute value of ln x. Okay, I think we've talked about that before, but here's ln x. And then anything that's above the x-axis stayed the same. Anything below, this part below, bounces above over here. So absolute value of ln x ends up looking like that. Okay, 5.4, number 4. I think I already did it, but somebody wanted to rehash that. So I Bacteria culture started with 8,500 bacteria, increased by 15% in the first 2 hours. Find expression for the number of bacteria after the culture was first observed. And then 8 hours, and then 35,000, and then triple. Okay. So 8,000, plug in 2 here. 9,775 represents a 20% increase. Okay, so that's where I get the 9,775 from. It's a 15% increase. So I multiply by 1.15. You divide by 8,500 and you get 1.15. Big surprise. E to 2k. Natural log both sides. These cancel out. And when 1.15 is 2k. Divide by 2. K is this. 0.06988. So this is my equation. Okay. Part B, plug in 8. Part C, they want 35,000. So put 35,000 here. Divide by 8,500. This reduces to 70 over 17. If you didn't do that, that's okay. But you'd have to keep this whole thing. Take the natural log of both sides. And then divide by 0.09688. So T is all of this, 20.25 hours.
In the text, like they don't get the answer of like the exponent, like 0.06998, they just keep it in LNs. Would you rather us like round it, or would you rather like this?
Yes, so in general, I want you to work it out like this. Okay, I think it's more meaningful to students than to leave it as ln some fraction and so on. So yeah, do it the way that we're doing it in class. Okay, besides it gives you concretely what that K is. So you can see what the K happens to be. Okay, D, triple. Well, triple 8,500 is 25,500. So I plug in 25,500 and I'll just say, etc. The rest is the same. I mean, work it out exactly the same as what you did over here. Okay, 5.217 says 1/4 of the x is greater than or equal to 2. Well, I know 1/4 of the x looks something like that. First, I find out where it's equal to 2, and then greater than 2 would be everything here. So I saw 1/4 of the x equals 2. 1/4 is 4 to the negative 1. So I get 4 to the negative x is 2. 4 is 2 squared. 2 squared to the negative x is 2 to the first power. Distribute here. 2 to the negative 2x equals 2 to the 1. So I got the bases to be the same. This is a typical technique for something like this. Get the bases to be the same. Once the bases are the same, the exponents have to be the same. X is negative 1/2. Okay, so this is negative 1/2. Where's the graph greater than 2? That's everything over here to the left of it. Okay, so the final answer is negative infinity, negative 1/2 bracket, or x is less than or equal to negative 1/2. That's where the y value is greater than or equal to 2. Okay, 5.4, number 5 was asked for. The radioactive isotope thorium-234 has a half-life of 578 hours. Do not use the 234. That names a particular isotope of thorium, so don't use 234 anymore. Half-life is 578. Okay, we start with 64 milligrams, find expression. I mean, once you have A, then B and C are typical. 75 hours, plug in T. 12 milligrams, plug in the left-hand side. Okay. Okay, so it says we're starting off with 64. Half of that is 32. 32 goes here. 578 goes in for time. Divide by 64. Get 0.5 equals e to the 578k. Take a natural log of both sides. After all these problems are the same. ln 0.5 is 578k. Divide by 578. Punch it in the machine. negative 0.001199. And yes, it does make sense that they come out with a negative, as it should, because it's a decay. So plug this thing back into here. So the equation looks like this. So if I plug in a t, I can find the amount. Or if I plug in the amount, I can find the t. So they say 75 hours, plug in 75. I'll save you the energy and time of punching it in. 58.50 milligrams, trusting you can punch this in your calculator. Part C, when were the 12 milligrams left? So that's on the left-hand side, that's my new amount, that's A of T. So 12 goes here. Remember, you're allowed to put sample problems on your cheat sheet, that's allowed. 12 equals 64 e to the kt, divide by 64. This is 0.1875, I guess, did it before. Equals e to the whatever. How do you get rid of e? ln. Same stuff. So ln 0.1875 is that. Divide by negative 0.001199. Punch it in the machine. 1396 hours. Okay. Although normally you wouldn't leave an answer like that. Okay, so you say, how long did it take? 1,396 hours. That's kind of weird. Change it to days. So I divided by 24, 58.17 days, which is approximately 2 months. Okay, so if you're going to give an answer like, explain it to the media or something like that, you would say 2 months. You normally would not say 1,396 hours. So we don't know what that means. So switch it to days or months in this case. Okay, 5.211, quick graph of e to the 2x. Okay, I just made a little table. I went from -2 to 2, plug in 0, you get 1. Plug in 1, e squared is about 7.4. Plug in 2, e to the 4th, 54.6. Okay, I'll actually show you e to the 4th power. So on most calculators, second function e to the x. So second function e to the x, and we wanted a 4. So e to the 4th power, 54.598, 54.6 roughly. -1 gives me -2. -2 gives me e to the -4. I'll show you e to the -2. Second function e to the x, and negative, again, for my calculator, negative is down here, -2. So e to -2, 0.135, call it 0.14. E to the -4, second function, e -4. Get this into focus. E to the -4, 0.0183. Okay, so it looks like that. So the horizontal asymptote is y equals 0, or the x-axis. Okay, and 5.2, number 5. So this is another one of those progression problems, right? You start with one function and then you progress by doing blah, blah, blah. Okay, so 1/4 of the x fallen, 0, 1. Triple it. So vertical stretch. So 0, 1 moves to 0, 3. And then what? 1 to the right, 2 up. So same shape as this red one. 1 right and 2 up moves me to 1, 5. So I just quickly went like that, 1, 5, and go like so. And where's my horizontal asymptote? Where it used to be y equals 0, or the x-axis, and we got shifted 2 up, so I just moved 2 up. So y equals 2 becomes a horizontal asymptote. Okay, so yeah, definitely be able to take a graph and then transform it, right? Move it, reflect it across the x-axis, y-axis, move left, right, up, down, whatever. Okay. Okay, 5.348. Okay. Yes, I know it's a even, but illustrate something. Log base 2 of 5x squared minus 8x equals 2. So unscramble it. 2 to the second power is equal to all this stuff. So we get rid of the log, right? We don't like logs. So write it without the log. 2 squared equals all this. And 2 squared is 4. Subtract 4. Use my quadratic formula. You may put the quadratic formula on your cheat sheet. So x is negative b plus or minus the square root of b squared, 64, minus, pretend it's a minus, 4 times a, 5 times c, which is negative 4. So that gives me a double negative. That's why I made them positive. All over 2a, 2 times 5. And 4 times 5 times 4 comes out to be 20 times 4, 80. 80 plus 64 is 144 divided by 10. Square root of 144 is 12. So I have 8 plus or minus 12 over 10. So 8 minus 12 is negative 4. Negative 4/10 is negative 2/5. And I plug in positive. 8 plus 12 is 20. 20 divided by 10 is 2. So negative 2/5 and 2. A quick double check. If I plug in 2, plug in 2, I have 20 minus 16. That's positive. But negative 2/5, it might be kind of hard to tell. Negative 2/5, 5 times negative 2/5 squared minus a negative 2/5. It'll be positive. Okay, this is definitely positive. We'll put a negative number here, it'll be positive. So I keep both of them. They're both good. Oops. Okay, and remember some properties of logs, and put these on your formula sheet if you wish. ln of a times b, ln a plus ln b. It works both ways. You can go left to right or right to left. Some of the homework problems, you go both ways. ln a over b is ln a minus ln b. And the power property, ln of x to the n can come down as n ln x, but you might have to go backwards and bring it up. So both of those are possibilities. Okay, cancellation laws. Anytime you have an ln and an e back to back, they cancel out. So ln e to the x is x, or e to the ln x is also x. Now, sometimes you get something like this where the 2 is in the way, quote unquote. So e to the 2 ln x. How do I clean that up? Just bring the 2 up, right? That's using this property right here. This 2 can climb up next to the x. So it becomes e to the ln x squared. Now the e and the ln are next to each other, and then I can wipe them out. So I have x squared. Okay, and then ln of 2e, as an example, that's a ln of a product. That's that thing. So it's ln 2 plus ln e. Ln e is 1 because ln e, you can pretend it's e to the 1. Then they cancel out, so you have 1. So ln 2 plus 1. Is that one? Okay, now if you get an equation that has an e, you can knock it out with an ln and vice versa. Okay, so for example, we did a lot of these, right? 7 equals e to 3k. Solve for k. How do you get rid of the e? ln. Right? So you get knocked out. ln 7 is 3k. Divide by 3. So k is natural log of 7 divided by 3. Punch it in your calculator. Right? Okay. So continuing on with more review problems. See 5.3, number 9. So log base 2 of 1/8 equals x. Okay. So they don't have to give you the x. If they just say log base 2 of 1/8, you call it equal to x. Okay. Unscramble it. 2 to the x equals 1/8. No more log. Okay, 1/8, I'm going to write as 8 to the -1 from algebra, right? And I know 8 is 2 cubed. So 2 cubed to the -1 is 2 to the -3. And now you can look at these two, right? 2 to the x equals 2 to the -3, then that exponent has to be -3. Okay, I do see something in the chat. I'll get it later, but I want to give my own, and maybe what I give on my own might answer some of your questions anyway. Okay, expand out ln of all this mess so that there's no quotient, no exponents. So ln 2x cubed over x plus 4 squared. Okay, so it's ln 2. Here's a multiplication, so it's plus ln x cubed. And since this is division, it's minus natural log of x plus 4 squared. And then exponents come down as coefficients. So leave this one alone, plus 3 ln x minus 2 natural log of x plus 4. Now, 29, they would have us go backwards, write it as a single log. So we're reversing this. So as I was mentioning for these properties that we've had, right? Be ready to go both ways, go left to right or right to left. Okay, you might go this way or that way, this way or that way. You should be ready for anything. So 29, put it all together. So these two exponents climb back up. So half goes up, 2 goes up. So it looks like this. And a minus sign means I want the ln of the quotient. So I turn it into a fraction. And x to the 1/2 means square root. So the best final answer, ln square root of x divided by x minus 1 squared, like that. Okay, then 41, and then I'll address the chat question. ln 2 plus ln x plus 1 equals ln 4x minus 7. Okay, there's a plus here. So ln of a plus ln b is ln of the product, a times b. So it's ln of 2 times x plus 1. Okay, so now it looks like this. How to get rid of an ln? Exponentiate, and it gets sunken down. So do not say divide by ln. I will take off points for that. It's not a multiplication. You do the opposite operation, the inverse of ln, which is e, the exponential function, and it gets sunken down like that. Then these cancel out. And once you have this, it's very easy, right? So 2x plus 2 equals 4x minus 7. Subtract 2x. Add 7. Divide by 2. So x is equal to 9/2. And quick double check, if I plug in 9 over 2, I'm not doing any negative there. And there's no negative there, so we're good. Okay, I have more, but I can save some of that for tomorrow too. Let me go ahead and check what's in the chat also. Okay, so let me write this down. So I have a request for 5.4, 9 and 11, and 5.2, 11. Okay. (5.2) 11 e to the 2x. Okay, yeah, I made a table. I know I did it today, but it's going to take me too long to find out where it was. You can always go back and watch the video, but I just plugged in numbers for e to the 2x. I just went like this. I know this is 1. This is e squared. And I think that was about 7.4. This e to the 4th, I think it was like 54 something.
Okay, but a -2 is e to the -4, right? I mean, like, I think
E to the -4. Yeah.
What you put like I thought you put like 54 there.
I put 54 here.
Oh, no, maybe I misread. I don't know. Okay.
Yeah, this is a very small number.
Yeah.
It's
Okay.
point
Thank you.
whatever, I don't know. Okay, is that good enough for this one?
Yeah, that's all I was
Okay,
confused about.
okay.
Thank you.
Okay, sure. All right, so that takes care of that. 5.4, number 9. 5.4, number 9. Find the half-life of rate of substance 220 grams to get to 200 grams in 4 years. Okay, so this is the initial amount, new amount times 4. Okay. So A of t is A0 e to the kt. Okay, 220 goes here, 200 goes here. And the time was what? 4. Okay. So divide by 220, divide by 220, cancel, reduce 10 over 11. 10 over 11 equals e to the 4k. Take a natural log of both sides. ln, that cancels out. ln of 10 over 11 equals 4k. Divide by 4, divide by 4. Okay, so ln of 10 over 11, natural log, parentheses 10 divided by 11, and the whole thing is divided by 4. Negative 0.023828. Natural log of 10 over 11 divided by 4. Negative 0.0238275, I'll call it 28. Okay, so the equation becomes A of t equals 220 e to the negative 0.0238828 t. Now we want the half-life. So I plug in 110 here. Right? So for the half-life, plug in 110. E negative 0.0238828 t. And just retrace my steps, sort of divide by 220, divide by 220. I know that's a half or 0.5. It's easy to punch in the calculator. E to the negative 0.0238828 t. Yeah. By the way, you do enough of these, you kind of know by experience what happens, right? So you might say, how come you left a space here? So why did I leave a space here? Because I know I'm going to write ln. Right? ln 0.5 equals negative 0.0238828 t. Divide both sides by negative 0.02, blah, 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 blah. And that should do it. 3828 divided by negative 0.0238828. So t is length. I forgot what the units were. Years. It's so many years. Okay, ln 0.5 divided by answer 29.1 years. Roughly. ln 0.5 divided by answer. Answer means I don't have to type in negative 0.023, whatever. Well, the calculator stores it all in memory. So let's use a little bit of time if I can get this in focus ever. Maybe I've never focused. No. There you go. And 11. Okay, the table gives estimates of world population, blah, 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 blah. Okay, use the exponential model and the population figures from 1950 and 1960 to predict the world population in the year 2050. Okay, so I'll just do A and B are similar. So the beginning of our experiment is considered 1950, of which the world population was 2,555 million. It's 2,555 million. Okay, so let me just start with that. A of T is 2,555 e to the k t. In 1960, the new population is 3040 and the time is 10. So 3040 equals 2,555 e to the k times 10. That's the number of years from 1950 to 1960, right? Okay, divide by 2,555, 2,555. Is it worth it to reduce? I can divide over 5 at least. 3040 divided by 5 is 608. Divided by 511 equals e to the 10. Okay. ln 608 over 511 equals 10k divided by 10. Function of the machine. ln 608 divided by 511, close parentheses, divided by 10. 0.01738 rounded off. ln 608 over 511 in parentheses divided by 10. 0.01738 So A of T is 2,555 e to the 0.01738 t. And now it says predict the population in 2050. So our starting point is 1950. So that's 100 years, right? So I plug in 100. So T equals 100. A of T is 2,555 e to the 0.01738 times 100. That's in the machine. 2,555. Second function e to the parentheses 100 times my answer. $14,528 million, it says, which means 14 billion, roughly. Of course, this is making some bold assumptions that the growth stays constant, which it normally doesn't. But that's why it's considered a model. So do the same thing for B. So use the data from 1990, and then 2000 would be 10 years, and then 2050 would be what, 60 years? Okay. So just do the exact same thing from there. Okay, I'm done for today, folks. I still have some more review problems. I can save that for tomorrow. So let me stop the share and check if there's any other questions in the chat. I don't see anything there. So anything else? Otherwise, we're done for the day.
Really quick on the inequality equations, your answer, like I believe 15 was 0 to 100. That's saying like when x is between 0 and infinity, right?
Okay, I'm not sure which problem are you talking about?
Like number 15 or I believe 17. It's your answer is like you gave a a set notation answer. That is for X, right? Yeah,
Yeah, that would be for X.
because
Okay.
X is an equation. Okay, yeah, okay, thank you.
Yeah, okay. Okay, anything else, please? All right, that'll do it for today, folks. So tomorrow, one more review session, and then Friday is going to be the test. All right, so have a good day, everybody. We'll see you next time.
Thank you.
Thank you.
Thank
Bye.
you, Professor.
Thank you. Bye.